Good morning, everyone. My name is Federico. I'm here with my colleague Enya. We're going to walk you through our experience on deploying Java 11 on AWS Lambda architecture for message processing. The business case that we dealt with is a large financial institution that needed to move transactions from a mainframe on premises onto AWS. They needed to do this to enable analytics, real-time insights, and effectively to be able to scale their transaction processing capabilities. We help them by building a AWS architecture with serverless, with Lambda. Obviously, we see here an extremely simplified view of what the architecture looks like. We have application on premises that sends transactions over a VPN connection to Kinesis. We have Lambda consuming the transactions from Kinesis and storing the contents in DynamoDB. At the bottom of the page, you can see an AWS user that is reading data through an AWS API gateway and Lambda from DynamoDB that we just saw. So the idea here is that we did a piece of work to measure the latency impact effectively and making sure that we could stay within the latency constraints that we had, the requirements that were significantly challenging. So we had to use Java for this work. And so we knew that we had to optimize for two reasons. We have to optimize cold start and we have to optimize execution. Two very different concerns. In cold start, we try to optimize by reducing the numbers of libraries that have been imported in a way that this would optimize our init time effectively. And we started to use provision concurrency, which is a feature that AWS enabled in recent times to effectively allow deployments on Lambda without the usual cold start problem. At execution time, we also did optimization by tuning the right memory allocation as usual, but also to move a significant amount of our code to our init function, especially DynamoDB clients, other third-party API clients into our init function. And then we build some logic to handle failures in that case as well. One point on Java as well is to make sure to monitor the framework that we're using and watch the framework that we're using, because obviously the framework has a direct impact on the execution times, especially in a Java environment. Let me just hand this over to Enya now.
Hi everyone, so I'm just going to run through the results that we got from our load testing. As Fed mentioned, we ran the load tests from on-premise so that we could get the most accurate numbers possible. We ran the load test in two stages. The first stage we load tested Kinesis, and the second stage we load tested against API Gateway. So our constraint was to be under 50 milliseconds. When we ran our tests against Kinesis, we used multiple Kinesis shards, we used enhanced fan out, and we had stream consumer enabled, and we had an on-demand DynamoDB table. That whole setup was done with speed in mind. So as you can see, our numbers are very good. They're well underneath what they needed to be. So the average time is 33 milliseconds. The P95 is 39.18 milliseconds, and the max is 387 milliseconds. We then went and ran our load test against the API gateway. We had a Lambda with provision concurrency and again an on-demand DynamoDB table. And again, the numbers are well below the 50 milliseconds. We have 28.59 as an average, 37.2 as a P95, and 2 seconds as a maximum. And I'm just going to run through the deployment experience. So we decided to use AWS native development tools. We have a mono repo for our Lambda function with continuous deployment multi-branch pipeline. We used the serverless framework for all of our Lambda functions and anything that the Lambda function needed, and used Terraform for our other resources. So we wanted the flow to be as seamless as possible. So you push your code to code commit, it automatically triggers a pipeline. That pipeline runs Maven clean install, packages everything together. It runs your unit and your integration tests. And then we have a manual approval step before it actually pushes out the deployment, just so you have that extra step of safety. We also use the canary deployment strategy so that we could slowly redirect our traffic to a new Lambda function instead of doing it all at once. And that just gives us more time to detect a problem, and any problem that does occur will have less of an impact. So the main takeaways that I would like you to take from this are here. Java can be optimized for low latency application on Lambda. Enhanced fan out increases throughput and reduces latency. Lambda destinations is a great way to do your error handling without having too much of an impact. Provision concurrency is a bit expensive, but I think, as we've shown, it significantly helps control the cold start problem and really gives you the numbers that you need. And Kinesis batch size tuning had more of an impact on average latency than JVM optimization. So just something to keep in mind if you have a similar setup. So I think that's our time. Thank you everyone for listening.
Hi everyone, my name is Mansa. I'm a full stack engineer at Theodo UK, and today I'm going to be talking about improving the serverless developer experience. So what's the current developer experience? Well, you make some code changes, you deploy them, and immediately you want to find out, has my function errored? Is it taking the same amount of time to run? How many times has it been invoked recently? All of these are very simple questions, but getting the answer to them is quite a clunky process. It requires navigating to our cloud provider's web console, potentially opening up a series of tabs, and for something that we're doing so frequently, getting this information seems like it could be a lot smoother. So how can we address this? Ideally, we want to collect all of this information and present it to the user in one place. And let's make that place the terminal. That's where SLS DevTools comes in. An open source project we've been working on at Theodo for a few months now, with the end goal being the equivalent of Chrome DevTools for the serverless world. HQ is one such tool, and that aims to solve the visibility problem I just described. So let's take a look at what it can do. Running the tool is as simple as SLS DevTools in your serverless project directory. You can install the tool using npm or yarn, and it automatically gets the region and stack name from your serverless config file. Here you'll see we have all of the functions on our stack listed with some information about the function configuration, and selecting one of these functions will show how many times that function was run in the past 24 hours, as well as all of the logs for that function and the most recent Lambda durations. We want testing to be as simple as possible when using HQ, so just press I and you'll bring up the Lambda invocation modal. You can supply a payload to the function, but just hit submit and you'll invoke the Lambda function all from within the tool. And if we give it just a few more seconds, we will see a brand new log and a brand new Lambda duration. There it is. Now, as more projects start to make use of events and Event Bridge, we want to make sure that HQ is prepared to support users in testing these events. So we added an Event Bridge section. Here we can list all of the event buses on our stack. And once again, pressing I opens up another event injection modal. Here we can type in an example, fill out these fields for the detail type and source. Once again, we can provide a payload, and pressing submit will inject the event onto the bus, once again, all from within the tool. Now then, what can we do beyond the feedback loop? SLS DevTools also offers support for the Event Bridge schema registry and provides fast shortcuts such as deploying your entire stack in a single key press. But we think we can do better. One of the main pain points that a lot of companies are facing as they adopt serverless is education. Due to serverless's steep learning curve, as well as its constantly changing nature at the moment, nailing down best practices can be quite tricky. And that's why we decided to make an addition to the SLS Dev Toolkit. SLS DevTools Guardian, a highly opinionated, highly configurable best practice audit tool. What does that mean? Well, if we run the same command as before, but this time add the --ci option, Guardian will run and immediately analyze all the resources on our stack. Here it's performing a series of checks, and as you can see, my stack has failed because it doesn't have a configured memory, timeout, or IAM policy for any of its functions. We have a series of URLs here that will take us to our docs page, which will give suggested actions on how you can improve this. As I said before, SLS DevTools is an open source tool. We love community engagement. A lot of our features have been directly from community suggestions as well as community PRs. You can chat to the team on our Gitter channel and follow all of the latest updates at SLS DevTools. We hope you enjoy trying out the tool. Let us know what you think, and thanks for listening.
Hey everyone, glad to be virtually here. I'm Luke and I'm a lead software engineer at Cancer Research UK. For those of you unfamiliar with that name, we are the world's largest charity dedicated to saving lives through research. Donations from our supporters are critical to the charity. Currently, 82 pence in every £1 donated goes directly to funding our research. From a software delivery perspective, we must do all we can to reduce operating costs. This particularly applies to infrastructure. Although our infrastructure is of critical importance to the supporter experience, from a supporter's point of view, this should just work. So we want to spend the majority of our resources on optimizing the product itself. Thanks to historic user data, we have a good idea of when our supporters are likely to donate and can anticipate regular spikes in traffic, such as in the evenings after work and around televised events at certain times of the year. Traditionally, this would have required a lot of planning and costly scaling of resources. We wanted to see if we could reduce costs, increase resilience, and scale on demand by moving to serverless. So, how are we designing and implementing a serverless donations platform? Firstly, we defined some guiding principles. We should go cloud native, moving away from on-premise. We should always prefer serverless managed services, and we should choose AWS first and embrace vendor lock-in. The architecture should also be event-driven and rely on service integrations for control flow, using as little code as possible. The diagram here shows the MVP we designed. Our donation app submits transactions via API gateway, which is backed by Lambda for processing those requests with an external payment service provider. We then use EventBridge to fan out events to multiple downstream consumers, like a transactional email service, transaction data storage in S3, and other systems like our customer data store and data warehouse. Serverless allows for rapid iteration of this MVP, whilst keeping costs low. But we needed a development workflow that complemented this paradigm to fully benefit from serverless. Continuous delivery has helped us unlock the potential to move fast and not break things. Although there are many definitions of this concept, we like Jez Humble and Dave Farley's definition of continuous delivery, which is underpinned by the requirement that your code is always in a deployable state. We enable our continuous delivery process in two ways. First, let's take a look at the life cycle of a feature as it moves from our local machines to our supporters. Our aim has always been to only maintain the environments that we absolutely need. For us, this is production and a set of ephemeral integration environments. Every environment we add is additional risk, increased overhead for us to maintain, and essentially erodes our confidence. We treat our code base as a single source of truth, and branches always map directly to deployed environments. Master is production, and every pull request is given its own integration environment. Automated status checks are our gatekeepers between the environments. GitHub Actions are used to start these status checks in response to code changes, and pull requests can only be merged to master once all these checks have passed. We use CloudWatch events to send the status of our code pipeline executions to GitHub. Our deployment pipelines are defined using the AWS Cloud Development Kit, and so is our entire infrastructure. With continuous delivery, change is constant, so it's crucial to have a development environment that encourages productive habits and is resilient to human error. We describe everything we possibly can in code and keep all our code in one place, in a monorepo. This includes the application code itself, infrastructure code, our deployment pipelines, our monitoring dashboards, and alert handling. The AWS CDK is key to us here. We also use a feature of the Yarn package manager called Workspaces that simplifies working with monorepos by sharing dependencies across microservices and utilities. As Lambda layers can be used to distribute shared dependencies to Lambda functions, we found that Yarn workspaces can be combined with Lambda layers for some real build and runtime efficiency. Dependencies do not need to be shipped with the Lambda deployment package, meaning our Lambda code is super lean and simple. All of our application code is written in Typescript and compiled to a single JavaScript file without the need for a complex build process or module bundler. We've only just started to realize some of the benefits of serverless. Cost is the most obvious, but also efficiency in terms of time and resource. Instead of managing servers, we can focus on creating the optimum experience for our supporters and direct more and more of their donations to fund research to bring forward the day when all cancers are cured. Thanks for watching.
Hi, I'm Rob, an architect developer at Theodo. Recently, I've been investigating people's experiences using DynamoDB to hear about the things they liked about it and the things they didn't. The things they liked were often linked to it being serverless, the fact that it scales well, that it's cheap, that you can create new instances whenever you liked. I was more interested in looking at things that they didn't like, and they often related to it not being agile to use DynamoDB. These were grouped together into these three, about having to know your access patterns in advance, about not being able to easily migrate your data if you make some changes, and about not being able to query the data you already have in your table. For the first one, if you look at any documentation or tutorials or watch any videos about Dynamo, you'll constantly hear that you have to know your access patterns in advance. And knowing this definitely helps you, but it doesn't mean you have to know your access patterns for the next 5 years, for instance. Knowing your access patterns for the next 12 weeks can be a good start. As long as you follow patterns such as overloading your indexes, you can future-proof yourself. Overloading your indexes means generifying them, not calling them user ID and order ID, but instead something like PK and SK. This means your indexes can be used for multiple access patterns in the future, and some patterns that you might not even know you have right now. For instance, I was talking to a colleague recently who had followed this pattern and had a new access pattern that they weren't aware of at the beginning. He was trying to avoid creating a new GSI just for this pattern. And after looking at his current indexes, he found that one of his GSIs already satisfied the new pattern. You're not always going to get this lucky, but by overloading your main table and all your GSIs, you're opening yourself up to this opportunity. And when you do get new access patterns, such as another group of features or epics that you want to build, you just follow the same pattern that you did before, making sure that you're overloading any new indexes and being efficient with the way you create your indexes. Next one is about migrating your data. For people coming from a relational database, they're used to perhaps writing new migrations every day, or the migrations being auto-generated for them depending on their framework. And then they hear that for DynamoDB, they're going to have to do a full scan of the table, they're going to have to paginate the data, filter some data, and then update the ones they need to. The thing is, these sort of migrations are much less frequent. While you might do them daily with a relational database, you only have to do them a few times a year on Dynamo. My most recent project, we only did it 3 times over about 15 months. The other thing is they actually aren't that scary. They're just a script you have to write that are quite formulaic. After you write a few, you'll get used to writing them. And if you follow some patterns, you can avoid writing some migrations altogether. For example, in a relational database, you'd write a migration if you were to add a new column to your table to add a default value to each row. For Dynamo, if you abstract your data layer to the edge of your application code, you can avoid some of these. Instead, you do a query on your data and you check if that attribute doesn't exist, then insert the default value you need. This will allow you to avoid writing some migrations. You can still write the migration if you want to, but you don't have to. And the last one is about querying the data you already have. Some of the biggest frustrations people have is falling into traps at the beginning that they didn't know they were falling into, and then not being able to query some of their data in the future. Dynamo has some complex attributes such as lists and maps. These are a very efficient way of storing your data in Dynamo, as they allow you to query your data all together. But the problem is they carry a cost. By using them, you're implicitly saying that you never want to query your data based on these values. And you need to understand the weight of that choice when you make it, and not everyone does when they first make them. There are ways out of this problem if you find yourself in it, but you want to try and avoid it as much as possible. So knowing all these pitfalls in advance, or the best practices, isn't always easy. At Theodo, we've started doing a DynamoDB workshop where we can work with you, look at the requirements of your project, and try to structure a DynamoDB table that follows these best practices and will hopefully future-proof you against some of your future access patterns. If you're interested in trying this out, send me an email and we can talk about it more. I've also written an article on this topic which goes into more detail into the three main topics I talked about. And that's it. So thank you very much for listening. If you have any questions, I will see you in the Q&A.
Hello everyone, and welcome to TypeScript Dynamic Typing with Serverless plugin. My name is Fred. I'm a web developer at Theodo, a French company developing web applications to solve business problems. Today we'll focus on three different things: AWS, then Serverless Framework, a famous infrastructure as code framework specifically designed for serverless application, and TypeScript. So what about those three? We'll try a little experimentation. TypeScript is a static typing language, meaning it's only checking type at build time, and we'll try to make it dynamic using a little trick from API gateway, and we'll do this on the context of HTTP request body validation. Let's take a first look at the basic HTTP Lambda example. Here we have a function taking as an input an event, which thanks to serverless will be the request object of our HTTP Lambda. We will extract from this event the body, and using the framework attribute of the body, we will return an HTTP response saying that whatever this attribute is awesome. Only problem we have with this is that framework attribute can be undefined, and the return response would be undefined is awesome. So the first thing we might do using TypeScript is to define a new interface. So let's define this interface myPayload and add an attribute framework, which is required to be a string. We can now, using TypeScript, say that the return type of the body will be of the type myPayload, and we can then have this attribute framework on body. Problem is, this is only weak type assertion of TypeScript, and it does not enforce that an input event shall have the framework attribute. Another thing we might think of is using the model feature of API gateway. As you can see here, we have a basic YAML example of a serverless framework configuration for the PaaS framework to run the code that we saw just before. Using those additional three simple lines, we can use the model feature of API gateway, passing a JSON schema template called framework.json that will enforce all requests coming to this endpoint to satisfy this JSON schema. In case they do not, API gateway will return a 400 bad request before even triggering our Lambda. The framework.json file could look something like this, to follow with the same example. We'll have inside a simple framework property of type string, and we will enforce this property to be present on the request body. Problem we have now is with those two implementations, I have on one side my JSON schema definition used by API gateway, and on the other hand, I have my TypeScript interface used by my code base written in TypeScript. So how can I make sure to use only my interface to generate my JSON schema? This will be done with custom code used during the deploy phase of serverless, and this will be done using serverless plugins. Everything is plugins within serverless. So whenever you run the serverless deploy command, which is deploying your infrastructure, what serverless will do is actually broadcast synchronously a list of events, the one you can see on the right here, for example, and some part of the code of serverless will react to those events being broadcast. First thing we can do to develop our own custom JSON schema generation is to register a new plugin, which is called Serverless TypeScript, by defining a new class and implementing an attribute hooks on this class. For example, we will have a hook on the specific event compile events of the deploy lifecycle. Doing so, we will ensure that during serverless deploy command execution, some code from our plugin will be run at this specific event. This is not doing anything at the moment, so let's add a new command on our plugin. This command will be API gateway generate. This will contain all the code relative to JSON schema generation and provisioning of the API gateway model feature. This command is not doing anything at the moment, but if we come back to our hook and basically spawn using the serverless context object the newly created command from our hook, we will have in our deploy lifecycle the command invocation as expected. It's still doing nothing at the moment, so let's add some events on the API gateway generate command itself. We'll have 3 events: compile type, generate JSON schema, and update function definition. Those events being now broadcasted by the invocation of the command automatically whenever you run the serverless deploy command. The last thing to do is to introduce the code which will do the compile types, generate JSON schema, and update function definition using the same hooks definition with our custom code logic. Doing so, we will have 3 different function execution defined within the class serverless Typescript, which will be playing anytime a serverless deploy command is run. With this, we can now get rid of JSON schema definition and versioning and use only our Typescript interface to generate those JSON schema and let serverless know what to do with those. To make sure we do it in the correct order, however, you can still use the before and after tag to make sure we do it before the rest of serverless work regarding the compilation of input events of Lambda. If you want to know more, please check my GitHub repository where this plugin is available, and you can use it already today directly within your serverless project. Thank you for your attention. Bye bye.